Grade 12s, we are looking at an analytical mechanical activity of which a detailed drawing of a front stub axle, a title block and a table of questions have been provided. The drawing on this side here has not been prepared to the indicated scale. Your instruction is to complete the table below by neatly answering all the questions which all refer to the accompanying drawing and title block. Let us zoom in and start at question number 1. On what date was the drawing checked? The drawing was checked by Casey and it was on this date, which is the 12th of the 5th, 2013. 12th of the 5th, 2013. Question number 2. What is the name of the engineering firm? The engineering firm is called Precision Engineering and they are situated in Durban. Question number 3. What scale is indicated for this drawing? You will find the scale right here in the title block and that scale is 1:2. Question number 4. What treatment must the stub axles undergo? That treatment you will find right here in your title block, which is hardening. Question number 5. On what date was the axle angle revised? If you go down to your revision table in your title block, you will find that these are the revisions, your angle, your holes in your axles, and that date was the 15th of the 5th, 2013, which was the date that it was revised. Number 6. What is the drawing number? You will find that drawing number in the title panel as AWF 3628W. Question number 7. What would view 1 be called? View 1 is this specific view that you will see here. There is a view 3 here on your side and view 2 on top. This view is called your front view, and the reason would be because view 2 is your top view. And view 2, which is your top view, is always situated or positioned above the front view. And this view here would then feature as your left view, which is on the left side of your front view. The answer to question number 7 would then be view 1 is your front view. Question number 8. How many surfaces need to be machined? So these are the machining symbols which you will see here appear on the drawing. It's a little triangle with an extension of the one side of the triangle. So you need to count all of those. So let's see. So this is referring to the rounded shape that you will see here. 1, 2, 3, 4, 5, 6, 7. If you look at these two components, you will see it appears 4 times. So there needs to be a double up of these two. So that's 7, 8, 9. That's a double up. Then we have 10, 11, 12, 13. If you go up here, you will find that you will have 2 here, 14, 15, 16, 17, because those refer to the 2 items that you will see here, which is that component there, which is this here, and that side there. So if you count it again, 1, 2, 3, 4, you will have 5, 6, 7, 8, 9, 10, 11, 12, that's a double up, 13, 14, 15, 16, and 17. So 17 surfaces need to be machined. Number 9. How many threaded holes are there in the stub axle? So if you observe clearly on this drawing, you will find that these are holes here, but they are not threaded holes. They are simply drilled holes. A threaded hole has a double circle like that there. So you will find there's a double circle, so that's a threaded hole. At the bottom there is one with a double circle. That's a threaded blind hole that you will see here. And of course these items here, they are represented by this side and that side there. So you have to double up on these two, which means that it's 1, 2, 3, 4, and there it indicates that it's a threaded hole there, meaning that your answer will be 4. 4 blind holes drilled 10 mm deep and tapped, which is the threaded part, to an M8 times 1.4. So 4 threaded holes. Question number 10. What production method is required to achieve the finish on the stub axle? Now if you go to your title panel, you will find that this is the machining symbol, which shows the turning there on top as your production method, which you are going to use during the finishing process of your stub axle. So your answer, turning. Number 11. What type of section is shown in view 3? This is view 3 that you will see here, and the only section area is going to be here, and you will find it has been opened up with a wavy line. The particular section that's associated with a wavy line is a part section. Question number 12. Name the encircled feature at 1. Number 1 refers to the double lines that you will see here, and it appears on both sides. When you see double lines like that, and it appears here in front, then you know that it is a threaded section. Number 13. Name the feature at 2. So number 2 refers to the little round out here, and that is classified to be a fillet. You will find many of these fillets will appear on your drawing. There's one, and there's one, and here you will find roundouts as well, which are classified to be fillets. Question number 14. What is the thickness of the feature at 3? We are specifically looking at this feature here, which is that area there, and this area over here, which is latched to these 4 circles that you will see here. And these 4 are represented by that part there and this part over here. And this inside part will relate to this part that you will see here. And if you scroll up, you will find that that size is going to be 4 millimeters. 4 millimeters. Question number 16. Name the type of curve which is formulated at 5. So here you will have the arc with a curve looking at number 5, and that curve is going to be situated on 4 parts. It is the welding area, and that curve is classified to be the curve of interpenetration. That is where the welding is going to take place, attaching this part to the main component. The curve of interpenetration. Question number 17. Determine the angle between the lines at 6. So here you will find the angle which you need to measure, and the tool which you are going to use is a protractor. So if this is the first line, you will see that it's open slightly way below this line here, which means that this line here is a 90-degree angle, so this angle has to be more than 90. So you need to put your protractor so that the bottom part lines up with this, and sometimes you need to extend this line so that it cuts through a particular measurement on your protractor. If you extend the lines and you put your protractor with the center point aligned to that point over there, you will find that this angle opens up and crosses through the angle of 100 degrees. Learners, please check if your answer coincides with mine of 100 degrees. Question number 18. What is the depth of the undercut? Learners, if you scan, you will find there is an abbreviation of U-cut, and that is your undercut, referring to this distance between there and that you will find is 2 millimeters. Question number 19. Determine the complete dimensions at A, B, C and D. Learners, here you will have A, and A refers to these holes that you will see here in this plate. You will not find the answer there. You will have to scroll down to your left view and find that those holes refer to these 4 holes that you will see here in your left view, which are these 4 ones that you see here, and the size of that hole would be a drilled hole of 10 millimeters or radius 10. If you look at B, B stretches from here until there. If you scroll down to your front view, you will find that B starts right here and it ends right here. So all these dimensions start from this particular point. So you have to take 90, which is your furthest point, and you will have to take 30, which is your starting point. 30 subtracted from the 90 will give you a distance of 60 from here to there. So your answer to B is 60 millimeters. C refers to the threaded part here. If you scroll down to your front view, you will find that this refers to that measurement here, which is an M16. And the 2 millimeters would be the 2 threaded parts that you will see here. So your answer would be M16. If you look at the width of D, that you will have to scroll down and find that particular answer right here, which is 8 millimeters. Number 20 and your final question. In the space provided in the title block here, you will have to draw in neat freehand the symbol for the projection system which was used. Then of course, you've done this numerous times before. Learners, you start with your little short line of your center and a long line on that side of your short one and a long line at the bottom, which is your center line here for half a mark. Your small circle, your big circle, both half marks, and then you will have a representation of your shorter version of your circle and a longer version of your circle on this side here, the connecting slanted lines, and of course the drawing being freehand will give you 8 half marks, which will equate to 4 marks. Grade 12s, that concludes another analytical mechanical activity. I hope that you have found this activity very informative. Please ensure that you fill in all the necessary answers in the designated spaces in your answer block.